Robotics and artificial intelligence are increasingly used in the field of nuclear decommissioning to de-risk operations and keep people safe. Embodied intelligence, or AI embedded in robots, is one of the core focuses at the Robotics and Artificial Intelligence Collaboration, or RAICo, which develops remotely operated solutions for decommissioning in high-risk environments, as well as for the operation and maintenance of future fusion power plants. To find out more about how robotics and AI are revolutionizing the nuclear decommissioning sector and the specialized skills needed to drive this future-focused industry, I spoke to Dr. Kirsty Hewitson, director at RAICo. Kirsty talks about the technologies RAICo is working on currently and why robots are simply one of the coolest tools in the industry. I'm Pamela Largue, and this is the Energy Transitions Podcast. Kirsty, thank you for joining me today to talk about robotics, AI, and nuclear decommissioning. What an interesting topic. I'm really excited to delve into this. But before we even talk about the nitty-gritties, what is it that you do? And do you perhaps have the coolest job in the world?
Thanks, Pamela, and thank you very much for having me today. My job title is Director of the Robotics and AI Collaboration, which is a 5-way collaboration between UK Atomic Energy Authority, the Nuclear Decommissioning Authority, Sellafield Limited, the Atomic Weapons Establishment, and the University of Manchester. And I can go into each of those partners in a bit more detail, but our overriding purpose is to develop robotics and AI solutions for nuclear decommissioning and fusion engineering challenges. So you're absolutely right. On one hand, I'm very lucky to have the job that I have. It's one of the few roles I've had where my family actually takes an interest because you get to show them lots of cool videos of robots walking around. And it's something which I think, the general public, because my family don't come from a technical background, they can actually relate to. And for me, again, we'll get onto it perhaps a bit later around skills and energizing the younger population. But robotics is one of those areas which really perks people's interests.
Well, I can tell you it piqued my interest, and I also don't have a technical background, but I do love watching videos of robots. Now, obviously, I mean, we talk about, fusion engineering challenges, there's nuclear decommissioning. These are really high-risk landscapes. So tell us a little bit more about these landscapes and actually why we need solutions like this.
Yeah, so I guess one of the whole mantras or reasons behind RAICo is around enabling missions within nuclear decommissioning to be achieved safer, faster, and more cost effectively. And that's not to say that the missions at the moment aren't safe, but it's very much around how do you remove people from harm. So if we think about some of the legacy facilities that we have in the UK, they're quite unstructured environments. And what I mean by that is that they're not necessarily fully mapped. So sometimes you have to go in and remap the area, understand exactly what the inventory is and where everything is in its place. And then you have contamination and you have radiation. And the preference is not to send people in. And at the moment, if they have certain levels of activity, you send them in different amounts of PPE, personal protective equipment. Some of that might be air-fed suits, which I guess to the listeners, that's a little bit akin to send them in a dustbin bag and they have a hose which comes off the back of them. And you can imagine that, back in the day, sometimes when people were going out running, they'd put a black dustbin bag on and run, and you sweated. Within these environments, you sweat, and you're putting them into active environments where, it might be a little bit warm as well. And so really you want to take people out of those uncomfortable situations. So instead, the whole premise of RAICo is how do you remove those people from potentially harmful and hazardous environments and send in the robots instead. And with robot technology improving, through the use of mobile platforms like drones and quadrupeds, now we should be really using this technology. But I think, main takeaway is when you think about a robot, we think about it as a cool bit of tech, something in the future. But actually, we should just be thinking of robots as tools. They're just another bit of our toolkit, which we can pick up and use and integrate with our other systems. It's absolutely not about replacing people. It's about just getting a few more tools in our toolkit, which we can use in order to do our jobs safely.
Yeah, as you say, it's not about replacing people. Although, frankly, if I was that person, I'd want to be replaced, because going into those environments sounds really, it's a little daunting. And obviously, as you say, high risk. I cannot fathom. What are some of the technologies that RAICo is working on at the moment that's really gaining a lot of momentum? And talk to us about how are these technologies developed? What is the innovation journey for something like a robot at RAICo?
Yeah, so I'll give you a real world situation that we're involved with. It was a building, a facility on the Sellafield site, and it was decided they wanted to do a clean and clear operation, a clear and clean operation. So whereby essentially they wanted to remove some hazardous bags material from one part of the facility to another. Um, and the operators of that site came to us and said, could we help? And we did this in partnership as well with the remote technologies group at Sellafield and with Atkins Realis as well. So again, emphasize that RAICo is a collaboration. So we don't work on our own. We engage with other companies and organisations as well. And as part of that, we decided, well, instead of sending in a human, we're sending a quadruped. So that's essentially it looks like a dog. It's a four-legged robot. But one thing we could have done is we could have sent them in with our own operators from RAICo or from the remote technologies group or for other people. But instead we decided, well, the people who know that facility the best are actually the operators who go in every day. So instead of our operators operating the quadruped, we took the operators from the Sellafield site, we took them off site for a couple of days, and we trained them to use the quadruped. We mocked up the environment, what it looked like on the inside, and we trained them to do the job that the quadruped would be doing. So again, this is around empowering the operators with the tools for them to be able to do it, rather than them thinking that robot's going to take my job, or we're going to have people coming in who are more skilled and qualified to use these robots. No, I mean, a lot of robots these days, you need some level of skill. But again, when we come back to the skills conversation, if you can use an Xbox controller, you can drive. I'm simplifying it a little bit, but you can drive some of these robots. So it's very much RAICo well is about developing the tools, then empowering the people to use those tools for them to be able to do their jobs. And I think when the operators first saw the quadruped, they were probably a little bit like, "What this toy is going to be able to help us to do our job?" When the reality is, you've got to change that mindset to be, no, it's just a tool. It's another tool, and as we become more and more familiar, we're seeing robots in our environments, whether it's at home, whether it's at work, whether we're out and about. Then I think people become more comfortable with the fact that robots are here not to replace their jobs. And certainly within nuclear, we're always going to have a human in the loop. Will be a while before we have autonomous systems going into high radiation environments.
How long have you been working in this industry, Kirsty? And the reason I'm asking this is because I'd be keen to understand how things have developed with the use of robotics, with the use of AI and digital tools. How have you seen the industry progress over time?
Yeah, so I guess my background's in technology translation. So I've worked across a number of industries from life sciences, defense sector, nuclear fission, nuclear fusion, and now the focus on robotics. And from a technology adoption perspective, I don't think robotics is actually any different to any other sector when you introduce new technology to it. There's always that initial there's the initial fear, or dare I say ridicule, around can that bit of tech really do what we're asking it to do. People are initially suspicious. People don't think, oh, can it do the job? And with anything, when we talk about technology, there's a number of things which accompany that. One is around communications, to make sure people feel comfortable with it. The second thing is around, I think, recognizing that technology does fail, particularly when you're trying to embed new technology. It isn't going to necessarily work right the first time, but let's fail quickly, learn lessons from it, make changes, and then carry on adopting again. And I think you've got to really work with your stakeholders on that communication piece around understanding, in the first instance, what's the need, what's the real use case. Because if you don't need a fancy tool, don't use a fancy tool, just use a stick. It's making sure that you don't overcomplicate things and just accelerate costs or bring in new technology which might not be as good. You should use the best tool that's available, and it doesn't necessarily need to be the newest, whizziest piece of tech.
Has AI made a big impact and really changed the way that you're working, or is it simply another stick that you are able to use?
Yeah, so I think when you think about AI with robotics, it's probably different to how most of us think about AI. So at the moment we have Chat GPT, which is around reviewing large data sets, large language models, doing rapid data interpretation on those large data sets, as I said. But when we think about it within the robotics arena, rather than calling it AI, actually we prefer to call about it as embodied intelligence. So this is more about how you can take the robot and you can embody the AI within the robot. So if you think about something like a mobile platform, again, whether it's a quadruped or a drone, it's as that quadruped might be walking around a facility, it's how do you use the AI which is embedded within it or embodied within it in order to enable it to make that decision making. So that's a little bit different from taking, large amounts of data and then doing the interpretation. It's almost around about doing that data on the fly and embodying that intelligence within the robot.
I can imagine that embodied intelligence, it's unique when it comes to the nuclear sector. The data that's gathered and how it's used. And obviously that's some of the focus then at RAICo as well, is how do you maximize that intelligence? Obviously, ultimately protecting people at the end of the day.
Yeah, but you can also think about, I guess, embodied intelligence from the way in which we might develop robots to interact and engage in, say, a social care perspective. So if you were to have a robot embedded within a home interfacing with somebody who needs caring for, they might have unstructured days. They might not necessarily do the same thing day after day after day. And they might want to have that level of engagement. And we're thinking a number of years perhaps in the future in terms of how do they engage with that robot, that tool, in order to make their lives and their days easier, and dare I even say a bit of companionship. But also, things like the construction industry, it's a structured environment, but there might be decisions that robots within that environment might need to take in order to enable full functionality. So I think as the area progresses, we'll see more interest in embodied intelligence, not just from the technical communities, but for example from investors, and thinking about wider use cases beyond areas such as ours, which have ultimately that initial interest. But I think it is broader actually than nuclear decommissioning.
Do we have the skills required to support this future vision that RAICo is working on?
I think at the moment, as with any new technology, as it's being developed, we probably don't have the appropriate skills base at the moment. But it also doesn't mean that we can't develop it. And I'll talk a little bit about some of the outreach activities that we're doing, particularly in West Cumbria. So the starting hypothesis is that robotics and AI will be adopted more and more at somewhere like the Sellafield site. Therefore, there's a growing need for that skills base. Yet within RAICo, when we go to recruit in West Cumbria, we actually struggle to recruit mechanical engineers, electrical engineers, roboticists, because actually when you think about roboticists, they generally come from mechanical and electrical engineering background. They've not necessarily done a degree in it or a PhD in it, and then we apply it to those robotic solutions. So we struggle to recruit. So we then think about outreach activities, but outreach in STEM is really difficult, because when you start to think about who do you need to influence when in order to have the engineers coming out when they're in from a degree or after their apprentice or from school, you probably need to go right back to primary school level. So then you need to think about that whole STEM outreach engagement piece. So some of the work we've been doing in West Cumbria is, first of all, we've been engaging with 16 to 18-year-olds through the development of something called robotic sprints. And we're doing that in collaboration with a local partner called the Industrial Solution Hub. And that's very much around going into local schools, and we run essentially a 4-week program with them where we go in for 2 hours every week, and we ask them to design a robot which can move along the track, pick up a fake waste container from one end of the track and move back to the other. And that robot is essentially it's like it's made out of Lego. So we give them the whole kit, and a couple of engineers will go into the schools. They'll help them build the robot and help them move across, teach them how to do the coding. And then at the end of that sprint, end of 4 weeks, they come to the RAICo 1 facility, and we did it with 3 colleges this year. They come to the RAICo 1 facility, then they have to do a presentation on what they've done, on what they've learned. So there's the soft skills piece. So that's all about communication, listening, teamwork, that presenting piece. And then they do a demo of what their robots learn. And then we announce a winner, but everybody gets a certificate. So that's very much around then engaging with those 16-year-olds to sort of like open their eyes and make them aware of what's available as a future career moving forwards. But STEM's really difficult and outreach, but we've certainly recognised that there's a gap there for us at the moment. The other way in which we're addressing it is through a program called CROSS, Cumbria Robotics Operational Skills Centre, where again the working hypothesis was that locally we don't have enough skills or enough talent at the moment. And so we did a landscaping piece of work to look more broadly as well, engaging with local companies as well as Self to say, what does that gap look like? How many people are we talking about? And what sort of skills from within the UK we have apprenticeships, which go from level 2 to level 8. And saying, where do we need that robotic skills on that ladder? And if so, how would we develop it? And rather than developing an apprenticeship program from scratch, what we've learned through engagement with our stakeholders and thinking about the skills needed is that we should take existing engineering apprenticeship pathways and develop robotic modules which slot into those pathways. So as people are developing as engineers, they can take robotics modules which are appropriate to their level of experience. But those robotic modules can then also be used in a standalone fashion with existing employers who can then take employees who might already be qualified to take them out of work and then put them on those robotic modules as well. And we'll identify a local training facility, we'll purchase the equipment, we'll put the equipment in the facility, we'll develop the curriculum, and then people locally will be able to use that moving forwards with the intention that the curriculum will be developed by the end of March, facility identified, and the kit, so that when the new term essentially starts in September 2026, we'll be able to roll out this more formal robotics training. So there's the outreach piece, but also the formal qualifications needed as well to be able to give people those skills to be able to take into their local employment.
You mentioned the challenges around STEM outreach. How receptive are girls and women to these opportunities? And, obviously as a woman working in the nuclear sector, in robotics within the nuclear sector, it's quite niche. How well represented are women? Is there a gap? Is there something that needs to be worked on, Kirsty?
Oh, definitely, yeah. So in a previous role, I worked on a volunteer basis for Women in Nuclear, which is actually I don't know if you come across them. They're a global organisation. So there'll be Women in Nuclear UK, Women in Nuclear Canada, and that's very much looking at addressing that gender inequality or gender gaps which exist within the nuclear sector. So in the UK, it's something like 20% of the nuclear workforce are females, are women. So there's a big gap in terms of inequality in terms of gender representation. And that's understood from a historical basis that if you look at different age demographics within the nuclear sector, as you move to higher age groups, you see a decreasing number of women. And sometimes that's, for historical reasons, because typically in the nuclear sector, people are employed in given roles sometimes for long periods of time. And so it's historical in terms of women and their entry points into the field. But then the other stat, which is a bit depressing, is when you look at areas where there might be 50% women and 50% male by profession, you find where there's that equality is around not necessarily what I would say the engineering subjects, but around professional services, where again, women very much do a valid job. But when we look at those STEM areas, that's where women still aren't very well represented. So without doubt, there is that inequality in terms of representation. And as a woman within it, I was very lucky that I had certain role models as I almost said, as I was growing up, but I'm quite old now. As I was moving through my profession, there are a number of women who stood out who are real role models. Fiona Raymond, Rebecca Weston, and others. But I think what you find is that because there's so few women, the same women are rolled out at every single event to represent that we have the equality. So how do you boost the numbers to show that there are opportunities? And it's really important, right, for women coming into the industry to see people in their own vision, to see people like them, and that goes as well for racial equality, LGBTQ plus, etc. You want to see people who look like you and who are like you, because that makes you feel as though you can get to that same position and that there aren't any barriers. And men play an equally important role because men make up a significant portion, particularly at higher levels, and so having male allies is super, super important.
I can only imagine that at RAICo, there are so many exciting things that are happening and a really bright future for anyone who might want to get involved. Kirsty, tell us a little bit about what RAICo is working on at the moment, if you can.
Yeah. So we have a number of projects that I can describe. So one is a robotic glove box. So for those people who aren't familiar, so a glove box is essentially an enclosed area where you have a number of ports cut into the side of the box, and you'd put your hands into there. And for those people who can't see, I'm mimicking this at the moment, so Pamela can see me mimicking me putting my hands into this glove box. So you put them in essentially through what looks like a pair of rubber gloves. And then on the inside are your contaminated materials and active materials, and you work in the glove box doing sample preparation, for example. The concern about that is that those glove boxes, whilst they might start off pristine and you can see through them, they become opaque, they get dirty, it's hard to see inside, and you may have sharps inside there as well. And so the worry is that you might get, stabbed through the glove, or the gloves might get cut. So one of the solutions that we're working on is called robotics. So essentially, we've taken a glove box and we've ceiling mounted two robotic arms. So instead of you having to put your arms into the glove box, you can then use two ceiling mounted robotic arms, which can then essentially do the same activities, and it can be controlled through automated moves. So if you're doing low active sample preparation, which is repetitive, you can have those pre-programmed moves. That's more of an automation type thing. It can be joystick controlled externally, or it can be haption controlled as well, which is where you get force feedback almost when you're doing the activities. So that's very much for new glove boxes. And I should shout out a project called Robo, which Atkins Realis have led on, and that's for existing glove boxes where you're actually putting robotic arms through the same ports and through the same gloves effectively into the glove box instead. But Robox is more for new glove boxes. And then we have something called Lyrob, which we're developing jointly with a company called Wallace Miller. And this again is where you have a through-wall manipulator. So you almost have now imagine instead of just a box, you have an entire room, an entire cell. And again, you have essentially almost like a large robotic arm which goes through into that cell, and you have it on the outside, which is the cold side, and the inside the cell where it's active, so they call it the hot side. And you have an operator on the outside, essentially using two levers to control the two arms. But that's quite cognitively intensive, but also quite physically intensive, because these robotic arms are at the moment cable driven. And so it requires a certain amount of effort, but the cables are also prone to snap. So with Wallace Miller, we've developed essentially a motorized electric motor-driven version, which again can be joystick-driven, but the ultimate aim being that you'll be able to use it off-site, so you don't need to be right up against the face of the active cell. You can be off-site. So that's kind of like some of the mechanical projects. And then on the digital side, we've been doing a lot of work recently on essentially training simulators. So if I give you an example from the Sellafield side, they have something called the Magnox Wharfs storage silo, which is where they keep old nuclear material, should we say, and they're trying to empty this silo out. So imagine like a grain store, and it's full of material, and they have an arm, a tailbot, which comes in at the top, and it picks up the material to take it out of the silo. So at the moment, that bit of kit, that tailbot arm probably costs, I don't know, close to £1 million to replace, and there's only one of them. So if you want to train up new people, then they have to train on the actual bit of kit, which obviously can, if you're one of the operators and you just started, and you want to be careful, right? You don't want to run it into the walls or anything like that. You don't want to cause damage, because if you damage it, then you take it out of operation. So with a company called Toya, again, this is the whole collaboration and working with supply chain. We've developed a digital training simulator, which looks exactly the same. When you look at it on the screen, the panel which they normally look through to actually see inside the silo has markings on it, and again, is a little bit opaque. We've simulated that exactly. Where the joysticks are now exactly the same position as when you're looking to see where the tailbot arm is. So it looks exactly the same in terms of replication. And now we can train people on that before they go into the real thing, which means that you may have fewer incidents, but also you don't have any downtime on the operations. You can carry on with operations. So there's lots of digital approaches as well, particularly around the training aspect.
It really is cool. I'm sold. And I can tell you, if somebody had come to me when I was a lot younger and said, would you like to perhaps go into a career in robotics? I would have said yes. And, I'm really pleased that RAICo is also participating in these outreach programs, because people need to know about what's out there and the opportunities. It's so exciting.
Yeah, and I have to admit, when you take we talk about robots being tools, and that is absolutely the message that we put into the workforce. They have to be taken seriously. But if you take a robot in with a bunch of kids, they get so excited. Everybody wants the photo taken with it. Everybody wants to have a play and a go on the robot. And that's great. That's what you want, right? Is to get people interested at that early age and to see what opportunities are out there.
Kirsty, I'm a kid. I want to climb on a robot and have my photo taken. So perhaps one day I can visit you in person and we can arrange that. One final question. Kirsty, just in terms of how you came to be in this field, and you're very passionate about the work that you do. How did you come to be where you are now? Was there a specific moment where you thought, okay, robotics, AI, nuclear decommissioning, this is the point, the pinnacle for me?
I have to admit, it's I've had quite a twisted route to get here. Not maybe twisted isn't the right word. Winding route to get here. So yeah. So my background, I'm an organic chemist, bioorganic chemist, molecular biologist, structural biologist by training. So undergraduate, doctorate, PhD, fellowship, all at Oxford Uni. And I honestly thought that I would be an academic for the rest of my life. Absolutely loved those, going into the lab, doing those Saturday morning experiments, feeling like, oh, maybe nobody else in the world has ever done this before. But then I had an opportunity to go into a spin-out company from the university based on some of the intellectual property IP that I'd helped develop. And very early on in the life of that spin-out, we partnered with a US life science company, quite a major deal, and that just absolutely opened my eyes to technology translation, about how you can take these early stage innovations from academia, which can be this melting pot, this center of where you have this creativity and these ideas and innovation. Not that you don't have them in industry as well, but how do you get them to the point whereby you have them in a lab, which at times can feel like a really privileged position to be working on them, actually to get them out into society where they can deliver value and deliver good. And that's really what my entire career has been focused on. So I worked with that spin out for a number of years, then it went into clinical trials, then we tried to reproduce that by engaging with a number of universities across Europe through a licensing deal model, before I ended up then randomly out in Finland for 3.5 years, helping set up the tech transfer office there, which was around life sciences, so medical devices, diagnostics, before coming back to the UK into the defence sector and doing the same thing. So trying to identify early stage innovations coming from the Defence Science and Technology Laboratory down at Porton Down. I was in the Chem Biorad division, and again translating them into both civilian sector and defence sectors, before jumping then into nuclear fission, so National Nuclear Laboratory, heading up their innovation and strategy. So again, how do you find those innovations and translate them? Before moving into Innovate UK, I was the chief exec at Innovate UK KTN, which is all about how do you connect people across the innovation ecosystem from academia, government, industry, before then coming back to be close to the technology and robotics and AI, because ultimately, when you think about technology translation and adoption, you always ask the same question. So, what's the need? Why we're building these things? Why we're making them? What's out there at the moment? How would this new technology be better? How long will it take to develop it? How much will it cost? What are the barriers? What's the intellectual property position? Who are your key stakeholders? So actually, I've gone from being almost this expert on a particular class of enzymes when I started my career to now being an absolute generalist, technology agnostic, because ultimately you always ask the same questions. And whilst the technology is important, you absolutely can't forget about the people and the skills that are needed as well.
It's basically the meeting point between academia and the creativity, the people, and the kit that's eventually going to have life-changing potential for people out there. And it is really about people at the end of the day.
Yeah, and I am truly fortunate to have the role that I have, because I get to play with some great technology, but also see it applied in those real world situations. But my job is one of stakeholder management, collaboration, and I can't do my job without other people, and that spreads a whole range of different people from. As we're talking about, engaging with local schools because they're future workforce, and we should be doing that, inspiring next generation and working with younger people, to working with the technologists, working with end users, and working with local communities. All of that's vitally important, because without collaboration, then life's a lot harder.
Well said. It's just been absolutely fascinating. So thank you so much for joining us.
Thanks, Pamela. And you would be very welcome in West Cumbria. Anytime you would like to come over and visit, you'd be very welcome, and we'll give you a tour of the facility and show you some of our technologies and introduce you to the people.
I'd love that. Kirsty, thank you. And thank you to our listeners. Until next time, goodbye. Thank you for listening to this episode of the Energy Transitions podcast, brought to you by Enlit and Friends. That's a wrap from me, Pamela Largue, and our producer, Kamo Motse. We hope you can join us next time. Visit enlit.world or subscribe for more episodes.